Okay, so first smells enter your nose. And they enter like a chemical. So you want to write that down on a piece of paper or on today's notes if you're able to print it out, where the page says smell, or it's also known as olfaction. Smells enter our nose like a chemical, and then inside the nose they dissolve into mucus. And you see this here is the olfactory bulb, which is attached right to the brain. The chemicals stimulate the hair-like endings of your olfactory receptors. And so there are these basically at the top of the nasal cavity and attached to the olfactory bulb near your brain are these hair receptors, like in the ear, which are stimulated by the chemicals. And then this generates a nerve impulse which travels directly to the brain. Remember, all senses go through the thalamus except smell. So for smell, once these receptors are excited in the nasal cavity and at the top of the nasal cavity in the olfactory bulb, it goes right into the temporal lobe and a little bit of the frontal lobe. And in this demo, it talks about igniting and interacting with the limbic system, which is the emotional system of our brain. If you remember the hippocampus and the amygdala and the thalamus. So eventually it goes to the thalamus, but smell doesn't need to be directed by the thalamus. So today we smelled objects and tried to see how long it would take to have sensory adaptation. Now, one type of sensory adaptation that I always think of is in the summer when you go swimming in a pool. And I know that when I was a kid, especially, oh good, Millersville Pool. There you go. Oh, here's an article. Utter surprise, a heifer found in a family swimming pool. That's a great article. On November 9th. Anyway, when I jumped in the pool as a kid, I remember thinking, ooh, it's so cold. Ooh, it's so cold. And then after some time had passed, I would think, oh, it's so much better. Okay, this is not what I wanted. I just wanted a picture of a pool. So if you think about a pool, that is sensory adaptation. It is not that the water got warmer, but that your neurons actually stopped sending messages to your brain about how cold the water is. Because if your brain didn't have sensory adaptation and your body didn't do this, then you'd constantly be going, it's so cold, it's so cold, it's so cold. Just like right now, you're probably sitting on a chair and your butt is on a chair, your butt is on a chair, your butt is on a chair. You weren't thinking about that because your neurons stopped sending those messages. Maybe there's a fan or some kind of buzzing in your house. You haven't been paying attention to that. Maybe now that I drew attention to it, you're now paying attention. So basically we have this sensory adaptation, and that's what we tried to do. We smelled a smell until we couldn't smell it anymore, until the message stopped being sent to our brain, and we timed how long that would take.